Hi there. Thank you for clicking on the all-important practice set for operations on polynomials, division. Please like and subscribe if this problem set is helpful to you. Ask a question to engage and check out the many other videos and playlists we have on the channel to help you with your math. As always, pause the video to work these problems on your own and then come back to check your work. Okay, so this first one is intended to actually help you draw the connection between factoring and division. And if somebody were to ask you, how do you undo multiplication? You could technically answer division or you could answer factoring. Both of those could fall under the umbrella of undoing multiplication. Now, this one is set up as a division problem. So we're going to go ahead and set it up as division. And we have a degree of 2, so we'll use 2 columns. And we know that the divisor, or one of the dimensions, is 3x minus 1. And we'll put the 3x squared in that upper left and then begin our division process. So what times 3x would give me 3x squared? Well, that would just be x. And then x times -1 is -1x. And then we look up here to see, okay, what do these need to add up to? They need to add up to a 5x, which means that this must be a 6x. And then 3x times what would give me 6x? And that would be 2. And then 2 times -1 is -2. Oh, I was not consistent with my colors. There we go. -2. And we can see that that matches what the area is. So there's no remainder. And so the answer would be x plus 2. Okay, and make sure that you are writing the answer, okay? Don't just stop with the area model. My students will tend to do that. And what it doesn't make clear is that you understand what in this problem is your answer. So you want to be really clear about that. Now, this problem could also have been done as a factoring problem. If somebody gave you the polynomial 3x squared plus 5x minus 2, and you were to set this up, okay, you would have the 3x squared and the -2, and then you'd have to go through this process here where you do 3 times -2 to get -6, and you would look for 2 factors of -6 that add up to +5. So you would have 1 and 6 and 2 and 3. Now, 2 and 3 do add up to +5 if they are both positive, but they would not multiply to give you -6. To get the +5, we would need this one right here. We need to have a -1 and a +6. And you could put these in either way, so -1x and 6x, and then you would do your GCF factoring. So what is the greatest common factor between 3x squared and -1x? You say, oh, well, that's x. And then x times what gives you 3x squared? Well, that would be 3x. 3x times 2 would give you the 6x, and x times -1 gives you -1x. And so your base is the 3x minus 1, and your height is the x plus 2. So that is the factoring version if you were not given either of the dimensions. And this one over here is the division version where you do know one of the factors and you just have to find the other one. All right, so a little bit of comparison contrast there. All right, for this one, so let's go ahead and set up our rectangle. The degree here is 3, so we're going to go with 3 columns. And my height is going to be x minus 4. And we'll go ahead and put the x cubed into that upper left. And then we start this process. X times what gives me x to the third? Well, that is x squared. X squared times -4 is -4x squared. Now you got to do some thinking, okay? -4x squared plus something needs to give me -x squared. And this is where a number line might come in handy. All right, I am sitting down here at the -4, but I need to be up here at the -1, which means I would go to the right 1, 2, 3, which means I am adding 3. And so this would be 3x squared right there. Again, you can just do that out in the margins. My students, I will provide for them, if they want one, a number line that they could just have at their desk and they could just move across on the number line. All right, so x times what gives me 3x squared? That is 3x. And 3x times -4 is -12x. And again, we got to play this game. I've got a -12. I need to add something to it to get -10. And that would be a +2. So that would be +2x. X times 2 would give me the 2x. And 2 times -4 is -8. Once again, that matches that, which means we have no remainder. And so our final answer would be x squared plus 3x plus 2 with a no remainder. All right, next one. Next one, we've got another x to the third. So when I go to set this up, we'll set it up with 3 columns. And my divisor this time is 3x plus 1. Using any other method for this would make this a really, really difficult problem, but it is no more difficult with this method. All right, so we're going to start with this 12x to the third. And we ask ourselves, 3x times what would give me 12x to the third? Well, to get the 12, I'll need to multiply by a 4. And to get the x to the third, it would have to be an x squared there, because x times x squared would give you x to the third. 4x squared times 1 is 4x squared. Now, 4x squared plus something right there has to give me 16x squared, and that would be 12x squared, because 12 plus 4 is 16. 3 times what would give me that 12? Well, once again, we've got the 4. And x times what gives me x squared? Well, this must be 4x. 4x times 1 gives me 4x in that bottom center. And then what do we have here? 4x plus something leaves me with 1x. Well, that must be -3, because 4x minus 3x would give me 1x. And then at 3x times what would give me -3x? Well, that is -1, and -1 times 1 is -1. Now, this time for the first time, these do not match. Okay, so we're going to need to figure out what our remainder is. So -1 plus what would give me -2? Well, that would be another -1. -1 plus -1 is -2. And so that is my remainder. So my final answer would be 4x squared plus 4x minus 1 plus -1 over my divisor, which is 3x plus 1. Or if you prefer to write it with the minus sign, okay, instead of the plus and negative, that is also correct. You don't have to write it both ways, okay? Just pick whichever is your favorite way, or whichever way your teacher requires, if your teacher has a preference. All right, on to the next. All right, so we have another cubic one. Now, these, quite frankly, are the most common ones, are cubics divided by a linear binomial. It's just the most common version of these we have. So on that one, my height is x minus 5, and we'll go ahead and put the x to the third in that upper left, and we're off. All right. So x times what gives me x to the third? That's going to be x to the squared. X to the squared. Oh, my word. X squared. Or x to the second power. -5 times x squared is -5x squared. And we got weird stuff happening. Okay, -5x squared, but I want a -5x squared, which means we've got that pesky 0 going on here. We're going to have a 0x squared. And then x times what would give us 0x squared? Well, that would be 0x, and I'm keeping the x there just because x times x would give me that x squared, and it preserves the pattern in the variables. 0x times -5 is 0x, because 0 times -5 is 0, and x, and you get the x there. And now 0x plus something has to give me 2x. Well, that would have to be 2x. And then x times what gives me 2x? Well, that's got to be 2. And 2 times -5 is -10. And we've got another remainder. Okay, so -10 plus what would give me -14? That is -4. So my final answer is x squared plus 0x plus 2 plus -4 over x minus 5. But we do not need to write 0x, so you are welcome to write x squared plus 2. And then you can use, as before, either the plus, negative, or the minus. I would probably write my answer the second way, but any combination there, as long as you're not writing something that is incorrect. Okay, so we've tackled that. Beautiful. Right, now this one breaks the pattern. So again, I am a huge advocate for this way of doing polynomial division because it is so versatile and it adapts to all different kinds of polynomial division problems that would otherwise be very, very, very difficult. Now, this is where the pattern of use the degree to determine the number of columns is going to break. But I want to show you what's going to happen. So the degree is 4, so I'm going to go ahead and set up 4 columns. Now this time, though, because of my divisor, I am actually going to need to set up 3 rows. Okay, and once again, we'll start with that x to the 4th. So again, if you try to do this using some of the other methods, which it's not even necessarily possible to do this with some of the other methods, the problems would be very, very, very difficult. It's just going to do the same thing. Okay, so we're going to start with x squared times what would give me x to the 4th. Well, that would be another x squared. And we're just going to multiply. We're going to figure out what both of these are. So x squared times 3x is 3x to the 3rd, and x squared times 2 is 2x squared. Now, as before, because again, this method is very versatile, we know that the x to the 3rds are on the diagonal. Now, we also know that the x squareds are going to be on that diagonal, but I don't have enough information yet to figure out those other x squareds. Like, I just don't. But I do have enough information to get the x to the 3rd part. I know that I've got 3x to the 3rd, and I've got 3x to the 3rd, and I need 5x to the 3rd. So this must be 2x to the 3rd. Right there. And now we repeat our process. So x squared times what would give me 2x to the 3rd? Well, that's got to be 2x. Now I can multiply to find these two. 2x times 3x is 6x squared, and 2x times 2 2x times 2 is 4x. I don't even know. I had like a brain fart there for a second. Now I do have enough information to find this. So 2x squared plus 6x squared is 8x squared. But I need a 7x squared, which means that I need to go 1 down, which means this must be -1x squared. And now we repeat the process. X squared times what gives me -1x squared? Well, that must be -1. -1, and we'll multiply to fill these guys in. So 3x times -1 is -3x. And then 2 times -1 is -2. And this one actually has no remainder. If I look at this, 4x minus 3x is 1x. And then I have the -2, which matches the -2. Therefore, my answer would be x squared plus 2x minus 1. And this is where it kind of breaks that pattern. Like I end up with this extra column here. And that's because the x to the 4th, I was dividing it by something bigger, so I didn't need as much space. Now, the same rules would work with the remainder. If this did not match up, we would put the linear piece of the remainder here, and we'd put the constant piece of the remainder here, and we would have some binomial, like, I don't know what it could be, like 5x plus 3 or whatever it might be, over the divisor. And so that would work as well. Thought that was maybe pushing the limits a little bit too much. And the chances that you'll ever need to see anything, you'll ever need to do anything this complicated are very rare, but it is awesome to see how the area model just keeps working with other variations of your polynomial division. And the last one, so the last one is one that we are dealing with the missing term. So our highest exponent there, our degree is 3. So we'll set up the 3 columns, and we're going to divide by x plus 1. And so this will be x to the 3rd, and we just start our process. So x times what gives me x to the 3rd? That's x squared. X squared times 1 is x squared. And now we've got this like weird thing, like there is no x squared there, which means that it must be plus 0x squared. So if I have a positive 1x squared, and I need a 0x squared, I must have a negative, okay? So x squared minus x squared, that would be 0. X times what gives me negative x squared? Well, that's got to be negative x. And again, I love, love, love this method because you can check your answer as you're going. X times negative x is negative x squared. Negative x times 1 is negative x. Now I have a negative x and I need a positive 2x, which means this must be 3x. Okay, 3x minus x would give me 2x. And then x times what would give me the 3x? That would be 3. And 3 times 1 is 3. Now we do have a remainder here because they do not match. I've got a 3. I need to be at a -1, which means this must be a -4. So my final answer would be x squared minus x plus 3 plus -4 over my divisor, or you can say x squared minus x plus 3 minus 4 over x plus 1. So that was just 6 problems. It took me under 20 minutes to do 6 problems with the explanation. Probably took you longer than that to do it. You might have needed to pause the video, make some corrections. That's totally okay. These are not typically filed under what we call like the easy problems, all right? And if you want to go back and like try them again, do that. It's kind of like doing a workout more than once. But that really gives you a good variety of what you can see and all the different levels of difficulty. Please don't forget to give this video a thumbs up if you found it helpful to review these polynomial division problems. Subscribe for more math content, drop a comment or question to engage, and check out the many other videos and playlists on the channel. If at the time I post this, I have my comparison contrast video up, I will link that below. Otherwise, see if you can find that on the channel. It should be in the Algebra 2 playlist. I hope to see you in a future video.